at PSN College of Engineering Technology. Today we discuss about basic fluid dynamics. Generally we know what is fluid, isn't it? But each and everywhere where you go, without fluid dynamics, what will happen in this world? Okay, first introduction. Fluid dynamics is the branch of science that studies how the fluid act, that means move, and the force acting on them. Like fluids are liquids and gases in the form. It explains the behavior of air, water, and other fluids when they flow, accelerate, or interact with solid surfaces. Okay, once again I repeat, fluid dynamics is the branch of science that studies how fluids moves and the forces acting on it. Okay, the fluids are liquid and gases, air, water, oil, whatever it may be. That's a fluid because it flows one place to another place. Now, why it is important? That is the major role. First of all, predict and control the fluid behavior. Then, second, how the drag is implemented and how it reduced and how to we improve the efficiency of the fluid and the machineries. Okay, then third, designing safety, because in aerodynamics or flight dynamics, safety is very previous role because the turbulence and disturbances arise. So how we will act, the major thing, design safe and reliable systems involving fluids. Okay. Then next, the properties of fluids. What are the properties it have? The fluid have. Okay. First of all, density, and it is represented by rho. Generally, mass per unit volume of a fluid, that is called density. That means rho, which is equal to mass/volume. It determines how heavy fluid feels. It's thicker or thinner. That is defined by density. Higher density, which is have higher density, that is a heavier fluid. Okay, water, for example, water, it is denser than air. Okay, next property is specific weight. Okay, specific weight, it is that is weight per unit volume, which means density into gravity. Okay, it is used in hydrostatics and pressure calculations. Then third property is specific gravity, that is the ratio of fluid density to the standard value of fluid. That means we know the density of water or air. Water means the density of water is 1000 kg per meter cube. If it is air, its the value is 1.225 kg meter cube per second. Okay, that is that. Then the specific gravity is a dimensionless. If the specific gravity is greater than 1, means the fluid is heavier than water. If the specific gravity of any fluid is greater than 1, which means the fluid is heavier than the water, it like heavier density. Okay, the next property is viscosity. It is represented by mu. The viscosity is nothing but it is the internal friction of a fluid which measures the resistance to flow. For example, honey has a high viscosity, water has low viscosity, because the honey is travel from one to another place, it take large time, but water will flow easily. We have two types of viscosity. First one is dynamic viscosity, then second one is kinematic viscosity. The dynamic viscosity is called sometimes absolute viscosity, and the kinematic viscosity, which is divided by mu divided by density. Okay. The next, temperature. Temperature is, we know, each and everywhere the temperature is present available. Okay, that directly and indirectly affect the density and the viscosity. For liquid, if the temperature increases, viscosity decreases. For liquid, temperature increases, viscosity decreases. For gases, the temperature increases and also viscosity also increases. This is the major thing, difference between the liquid and gases, which affects the density and viscosity. The next property is pressure. Pressure means the area exerted by the any force, that is called pressure. The fluid always exert pressure normal to a surface, which means perpendicular to the surface. The fluid pressure is the fluid, any forces act on a fluid. Okay, that is pressure. That is classified by the vapor pressure. Vapor pressure means the pressure at which a liquid starts to vaporize. If any liquid, for example water, at any pressure it will vaporize, that is called vapor pressure. Low vapor pressure fluids boil easily. Low vapor pressure fluid boils easily. Okay, the next slide. Compressibility. What is compressibility? Compressibility means the ability of a fluid to change volume under pressure. That is called compressibility. For a take a glass tube, you take a glass tube and put the tube into the water container. The water will rise spontaneously. Okay, that is called compressibility. Liquid is almost incompressible. Okay, we can't compress the any fluid easily. Okay, and some fluids are maybe compressible, but all the gases are highly compressible. It also compressed by any compressors. Okay, compressor, any external aid mechanical devices. Then surface tension. Surface tension means force that causes the surface of a liquid to behave like a stretched membrane, responsible for droplets forming and insects walking on water. These are made by the surface tensions. Once again I repeat you, force that causes the surface of a liquid to behave like a stretched membrane, responsible for droplets forming and insects walking on the water. That's why the water on a lotus leaf, not adhesive on a water leaf. The next, capillarity. Rise or fall of a liquid in a narrow tube due to surface tension. Due to the surface tension, the fall will rise or drop down in a glass tube. That is called capillarity. Important in soil, water movement and plant transport. This depends upon the capillarity phenomena. Okay. The next slide is pressure in fluids. What is the pressure? Already we discussed what is pressure in fluids. Pressure in fluid is the force exerted by a fluid in per unit area. Fluids, liquid, we know about liquid and gases. These are the fluids because it moves from one place to another places. Exert pressure because their molecules move continuously and collide with surfaces. That is called pressure in fluids. Next, the definition for your pressure: the force exerted by a per unit area, where the P is equal to pressure, F equal to normal force applied, which means the force acted on perpendicularly to the surface, then finally area on which the force acts. Okay, the unit is Pascal. If it is 1 Pascal equal to 1 Newton per meter square, then Pascal law. What is Pascal law? The pressure applied at one point, of an enclosed fluid, which means closed fluid, is transmitted equally in all directions. If I apply the force on a container with contain the fluid, if I apply the force is transmitted to along all the direction eventually. Okay, that is Pascal law. In this, the Pascal law applications are hydraulic lifts, brakes, press machines. These are application under the Pascal's law. They are working under the Pascal law. Okay. Next we move to atmospheric pressure. What is the atmospheric pressure? The pressure exerted by the air above us, because at a sea level, what the pressure we have it, that is atmospheric pressure. Okay, we know some cases atmospheric pressure, absolute pressure, gauge pressure. We are seeing back. Okay, at sea level, the atmospheric pressure value is 101.325 kilopascal. In some case, 1.01325 pascal also. Okay, then it is measured by a barometer. The pressure is measured by a barometer. It will decreases when the altitude increases. Okay, if the altitude increases, the pressure will also, atmospheric pressure also decreases. Next, gauge pressure versus absolute pressure. What is gauge pressure and what is absolute pressure? Absolute pressure is nothing but it is measured from a perfect vacuum. The vacuum becomes zero. The value is zero. We take at the point we take a pressure value. What is that? What the value? We have it. We get it. That is absolute pressure. And the gauge pressure, it is related to the atmospheric pressure. It is related to the atmospheric pressure. The pressure measure related to atmospheric pressure. Okay. The next, hydrostatic law. What is hydrostatic law? Hydrostatic law describes how pressures varies in a fluid at a rest. The pressure, if we take a fluid, a container, it is filled by the water or any substances, any liquid fluid substances. How the pressure varies at a rest? Because the container contains water at a rest manner. And this at this position, how the pressure act at a fluid. That is hydrostatic law states that since a stationary fluid has no shear stress, if the fluid is moving it has shear stress, but the stationary fluid has no stress. Okay, the pressure at any point acts equally in all directions and increases only due to the weight of the fluid above. And once again I repeat you, the pressure at any point acts equally in all directions at stationary fluid. That means we are at rest, and increases only due to the weight of the fluid above. Okay. The next statement of hydrostatic law, dP by d is set equal to minus rho g. Okay, where the pressure increases with depth. Pressure increases with depth. Pressure decreases as we move upward, because if you fall down in a well, high depth well, we get a difference between the high depth and low depth level. Our ears are very, we feel our ears get very pain. Okay, due to the pressure level variations. Okay, here P equal to pressure, Z is the vertical coordinate, positive upward, and the rho is the density of the fluid, G equal to acceleration due to gravity. We know about value 9.81 meters square per second. Okay, then next, pressure depth relationship. What is the pressure depth relationship? It means the pressure at the depth equal to pressure at the fluid surface. It's the summation of depth rho g. It means gravity level, gravity, the product of gravity, density of the fluid in the depth measured downward. Okay. Conclusion: pressure increases linearly with depth. Okay. Pressure increases linearly with depth. This is we get the knowledge from the pressure depth relationship. And that last one, hydrostatic assumption. What are the hydrostatic law assumption? First one is fluid is at rest, no motion. Then second one is fluid is incompressible, because incompressible means we can't compress the fluid at any time. Okay. Then third one is density is constant. Without compression, density is not change, never change. Okay. If the fluid is come to the compressible manner, definitely the density or value will be changed. Okay. And also the gravity is constant. Yeah, the gravity is always constant. Okay. The next, pressure direction in hydrostatics. What the pressure direction by the hydrostatics? But in a static fluid, the pressure acts normally to all surfaces. Pressure acts normally to all surfaces. The next point is pressure is the same in all direction at a given point. Pressure is the same in all direction at a given point. This is the pressure direction in hydrostatics. The next, application of hydrostatic, where we used the hydrostatic law, designing water tanks. new tanks, constructing new dams and canals. We follow the hydrostatic law. Next, we calculate the pressure on submerged surfaces. Then third one, manometer and barometer analysis. The fourth one, ocean engineering and submarine designs. Fifth, blood pressure levels. That means medical applications. These are the following the hydrostatic law. Next, buoyancy. Buoyancy is the upward force exerted by a fluid on your body that is partially or fully submerged in it. This force acts opposite to gravity and is responsible for making object floats, rise and feel lighter in fluid. By the buoyancy, with the help of buoyancy force, the ships are floating above the sea, any fluids. Okay, that is buoyancy. Next, cause of buoyancy. The buoyancy occurs because the pressure in a fluid increases with depth. The next point is the bottom of an object experiences higher pressure. The bottom of an object experiences higher pressure than the top experiences lower pressure. The difference creates net upward forces. The bottom of an object experiencing higher pressure, the top experiences lower pressure. Due to the difference, it creates the upward force. That's why the ship float on the sea. Okay, this is the cause of buoyancy, because pressure, volume, temperature, and these pressure, temperature, volume, these also come from higher body to lower body easily, spontaneously, without any external aid. But lower area to higher area, it needs some external aid. That is the major thing we know about in engineering terms. Then Archimedes principle: the buoyant force on a submerged body is equal to the weight of by the body. But that means FB equal to body force. The FB means body force, which is equal to rho G into V. Rho already we know about. Rho is the density of fluid. G is acceleration due to gravity. V equal to volume of displaced fluid. Volume of displaced fluid. Okay. Condition for flotation. Flotation means for a body placed in your fluid, if body force is equal to weight, it floats in equilibrium. Body force which is equal to weight, the object floats in equilibrium. If the body force which is greater than weight, the object will rises. The object will rises. If the body force less than weight, the object will sinks. The object will sinks. This is the condition for flotations. The next, apparent weight loss. What is apparent weight loss? The apparent weight loss is nothing but when an object is submerged, it feels lighter due to the buoyant force. When an object is submerged, it feels lighter due to the buoyant force, which is equal to weight difference the body forces. Okay, this explains why it is easier to lift heavy objects under water. This explains why it is easier to lift heavy objects under water. Factors affecting buoyancy. What are the factors affect the buoyancy forces? First one, density of fluid. Second one, volume, submerged. Third, shape of the body. The fourth one, fluid temperature. Because already we discussed in previous slides, the fluid affects the density of your fluid. Okay, that is the major thing to affect the buoyancy forces. Next, manometers. The manometer, the olden days we using to find the pressure or measuring the pressure, we using the manometers only, barometers only, because the manometer is a single device. It is used to measure pressure or pressure difference in fluids. Okay, it works on the principle of hydrostatic pressure. Using the height difference of your liquid column to determine pressure. Using the height difference, it works on the principle of hydrostatic pressure. Using the height difference of your liquid column to determine pressure. Principle of manometers. Based on the relations, pressure equal to rho G H. Rho is the density, G is the gravity, and H is the height difference liquid columns. And the types of manometer, we know the simple U-tube manometer, differential U-tube manometer. Okay, these are the inverted U-tube manometer. These are the types of manometer. First we discussed simple U-tube manometer. It consists of a U-shaped glass tube and it is partially filled with a liquid. That means manometric fluid, mercury or water. One end is connected to the pressure source, the other end is open to atmosphere. This is the major thing we know to connect the manometers. Pressure is found by measuring the height difference between the H1 to H1 and H2. The difference is if the pressure is H1 is 10, H2 is 20, we get the value, pressure value is 10. Okay, this is the height difference between the two columns. It is used for measuring the gauge pressure value. We get the gauge pressure value from the simple U-tube manometer. Next one is differential manometer. It is used to measure difference in pressure between 2 points. Both ends are connected to different pressure sources. Both ends are connected to two different pressure sources. Height difference of liquid shows the which means the pipe, we connect the differential manometer between the input of the pipe, inlet of the pipe and the outlet of the pipe. We get the pressure value of these two area by the column differences and the pressure differences with the help of water rise and water fall. Okay, the height difference of fluid shows the pressure difference. Then used for fluid systems and pipe pressure comparisons. Then third one is inclined manometer. The inclined tube inclined at a small angle, it has a negligible amount of angle, but the inclined manometer gives more accurate measurement for small pressure difference. More accurate measurement for small pressure difference because length reading is magnified. Length reading is magnified, used for low pressure measurement ventilation system. The ventilation system using the inclined manometer. And we get a knowledge about manometer and what are the manometric fluids we using in the manometer. Okay, first commonly the fluids are mercury, water, alcohol. Because why we using mercury means the high density suitable for large pressure values. If we need a large pressure values, we using mercury. If we need a low pressure values, we want a low pressure value, then we be using water. For special applications, the alcohol, oil are used in some cases. These are the manometric fluids we using in manometer. Then applications, measuring gas pressure in pipes, laboratory pressure measurements, calibration for pressure gauges, ventilation and HVAC systems, hydraulics and fluid mechanics experiments. What are the advantages we get from the manometer? Simple and accurate, no calibration needed, low cost, works without electricity. Because this is the very important advantages. Okay. Next, limitation. What are the limitations in manometer? Not suitable for very high pressures. If we need we get the value from high pressure sources, we using gauges, pressure gauges, Bowden gauges. The next, reading errors possible. Temperature changes affect accuracy, slow response time. These are the limitations. Then, in fluid mechanics, very important thing is continuity equation. What is continuity equation? The conservation of mass is the continuity equation. We simply say that the conservation of mass in the fluid flow, that is called continuity equation. It states that the mass cannot be created or destroyed, therefore the mass rate remains constant. That is stated from a continuity equation. Remains constant from one section of a pipe are flushed into another. Physical interpretation of continuity equation. What is the physical interpretation? The fluid speeds up when the area decreases because the same amount of mass must pass through each section in the same time. The fluid speeds up when the area decreases, the fluid will speeds up because it equalizes the amount of mass is exit from the exit area. Okay. Example, water flowing in a river becomes faster where the river becomes narrow. Water flowing in a river becomes faster, where the river becomes narrow. Then second example is airflow speeds up in the throat of a nozzle. Airflow speeds up in the throat of a nozzle is the one of the example for communication. Bernoulli's equation. The next one is very important for Bernoulli's equation in fluid dynamics. This is the major phenomenon to create a lift in the aircraft. Fundamental principle in fluid mechanics relating pressure, velocity and height. This is the major thing to determine the Bernoulli's equations. Energy conservation for flowing fluids, and third one is state the total mechanical energy along a streamline is constant. Along a streamline is constant. For incompressible non-viscous, it is only applicable for not for incompressible and non-viscous fluids. The Bernoulli states that P, which is P plus half OV square plus rho G H, is called to constants. P is represented as pressure, energy per unit volume. O is fluid density. V, which is equal to flow velocity. H equal to elevation, where how the object is, placed. That is the elevation from the ground level. G equal to acceleration due to gravity. Application of Bernoulli's principle. Here I already said that airflow over means that which is help to generate lift. Then venturimeter, it measure the flow rate. Pitot tube, it also measure the airspeed, flow pipe, flow in pipes and open channels. Okay, application of Bernoulli's equation, venturi effect, lift generation, flow measurement device already discussed. Then next we move to flow patterns. Flow patterns describe the behavior of fluid motion. Flow patterns describes the behavior of fluid motion. First one is laminar flow. Laminar flow means less than 2000. It depends upon the Reynolds number. Smooth orderly layers occurs at a low velocity and Reynolds number. Turbulent flow means chaotic and irregular motion occurs at high velocity and Reynolds number. Transitional flow means intermediate between laminar and turbulent. Okay, intermediate between laminar and turbulent. Understanding the flow patterns is essential in pipe design, aerodynamics and fluid machinery. If the Reynolds number is less than 2000, it will laminar. It will if it is above, it will change the transitional flow. Then control volume approach. Control volume approach is a method to analyze the fluid flow by focusing on a specific region in space. To analyze the fluid flow by focusing on a specific region in space. The next one is that it involves a control volume through which the mass and energy can cross its boundaries. It involves a control volume through which mass and energy can cross its boundaries. Okay. Used to apply conservational laws, mass, momentum and energy equation. In this control volume approach, we using it kinetic equation, energy equation and momentum equation also. Here simplify the complex fluid systems by analyzing inflow and outflow, widely applied in turbines, pumps, nozzles and pipe flow analysis. Inviscid flow. Inviscid flow means inviscid refers to the fluid flow where viscosity is negligible. Refers to fluid flow where viscosity is negligible. That is called inviscid flow. Assumes no internal friction between the fluid. Becomes the shear stress are zero. So shear stress are zero. Because you don't have an internal friction between the fluid particles. Simplify analyzing using Miller's equation instead of Navier-Stokes equation. Then commonly used in high speed aerodynamics and ideal fluid theory, and also they are using high speed aerodynamics and ideal fluid theory. This helps understand pressure and velocity distributions without viscous effects. Then boundary layer concept. Boundary layer concept in fluid dynamics, aerodynamics. This is the very important concept in fluid dynamics and aerodynamics, because each and every fluid moves from one place to another place, the boundary layer is placed there. Boundary is a thin layer of fluid near a solid surface where the viscous effects are significant. Where the viscous effects are significant, at the place the boundary layer is placed there. The velocity changes from 0 at the wall to free stream velocity, that is called no slip condition. At the point the velocity becomes 0, that is called no slip condition. Can be laminar, it is smooth or turbulent. Shorty thickness increases along the surface due to friction and momentum diffusion. Due to the friction and momentum diffusion, we get a smooth and turbulent flows. Okay, and critical in aerodynamics, drag reductions and heat transfer analysis. Boundary layer thickness, it is represented by del. It is a distance from a surface where the fluid velocity reaches 99% of free stream velocity. Where the 99% of the free stream velocity depends on flow type, laminar layers and thinner, turbulent, and layers are thicker. Turbulent layers are thicker, and then increase along the surface in the flow direction, determining the using viscosity, velocity and characteristic length. It is important for drag calculation, heat transfer and aerodynamic design. Also they will be using the boundary layer thickness concept. Okay, next, boundary layer separation. What is the boundary layer separation? If it met any object, the separation will occur. The boundary layer separation occurs when the fluid near surfaces loses momentum and it detaches from the surfaces caused by adverse pressure gradients opposing the flow. Which leads to flow reversal, increased drag and losses of lift. Due to the boundary layer separation, we increase the drag, flow reversal and loss of lift. And more common in turbulent and high flow angles, and more common in turbulent or high angle flows. Then finally, critical in aerodynamics, turbine design and vehicle drag reduction. Then drag in fluids. The drag is nothing but is the resistive force experienced by an object moving through a fluid. Drag is the resistive force experienced by an object moving through a fluid. It depends on fluid density, velocity, object of shape and surface roughness. And it's the types of drag. We know about pressure drag, that is called form drag, and friction drag. It is caused by viscous force, that is called friction drag. Okay, this is the drags in the fluids. Next, lifting fluids. What is lift? We know about drag. Drag is the one more thing I explained it. What the lift is equal to? Drag is equal to half rho v square, which means dynamic pressure into spandrel area and drag, the coefficient of drag. Okay, that is the drag formula. Then next we move to next slide. Lifting fluids. Lift is the force perpendicular to the flow direction experienced by a body in a fluid. Whether it is a liquid fluid, whether liquid or air. Okay, generated due to pressure difference on opposite sides of the body. For example, airfoil. The upper curvature have a generate a low pressure value, but the airflow moves faster than the lower surface. Due to the pressure difference, the lift will generate. Okay, according to the Bernoulli's principle, below the airfoil, the velocity is too low, but the pressure will rise. Upper surface, in the upper surface of the airfoil, the pressure is too low, but the velocity is high. Due to the difference between the upper and lower area pressure difference, it will generate a lift. Depends on fluid density, velocity, surface area and shape also. Then airfoil. Airfoils are specially shaped design, surfaces designed to generate lift. When the flow overs them, it will create a lift. These are the major components in airfoils: leading edge, trailing edge, camber, call line, and thickness. Leading edge is nothing but this area has a more area in the airfoil. In this area, the air strike and separate the flows. Separate the flows means is divide the flow of the air and to lead to the trailing edge. That is called leading edge, and the trailing edge is the end of the flowed object. That is called trailing edge. The camber is the upper. It's classified into upper camber, lower camber. Okay, it is divided by the mean camber line, and the call line is nothing but it's the connect the leading edge to trailing edge, and the finally thickness where the maximum thickness and where the maximum camber line camber thickness. Okay, that is the thickness. Then third, the shape affect the lift, drag and stall characteristics, because the perfect design will produce more lift. This is advised by the NACA series, NACA committee, National Advisory Committee for Aeronautics. They give some guidelines to how the airfoil shape is available and how do we generate more lift, how get the more lift. The flow over airfoil is flow, Bernoulli's principle and circulation theory. Then finally, it is used in aircraft wings, helicopter blades and turbine blades also. Then what is it? What is it? Is a measure of the rotation or spin of the fluid particles in a flow. Verticity is a measure of the rotation or spin of the fluid particles in a flow. It indicates region of swirling or rotational flow. It indicates region of swirling or rotational flow. Zero vorticity correspondent to irrotational flow. Important in aerodynamics, vortex formation and turbulence analysis. The zero vorticity corresponds to irrotational flow. Important in aerodynamics, vortex formation and turbulence analysis. And the lifting fluids. This is circulation by the lift. Circulation is the line integral of velocity around a closed curve in a fluid, that is represented by closed curve, and the V is the velocity and D is the control surface area. Okay, this is a mathematical term, kappa. It represents the circulation. It measures the rotational strength of a vortex or fluid region. Vortex measure the rotational strength of a vortex or fluid region. It related to lift generation via Kutta-Jaworski theorem. It is used in aerodynamics, vortex dynamics and fluid analysis also, because circulation is very important thing. Where is the local circular velocity or vorticity is available here? What is that? The next one is source and sink flow. Source flow is nothing but source flow is where the fluid emanates outward from a point in all directions. The source flow is where fluid emanates outward. The flow is outward direction, moves around outward direction from the point in all direction like a sun. Okay. The next one is sink flow. Sink flow is where the fluid converges. It's moved to the point. That means inward to a point, that is called sink flow. Okay. The both are idealized, irrotational, incompressible flow, velocity potential and stream function describe the flow patterns. They are describe the velocity potential and stream functions. Then used in superposition for flow analysis and potential flow modeling. Used in superposition for flow analysis and potential flow modeling. Next, doublet flow. Doublet flow is formed by a placing here. It's a combination of source and sink flow which is closed together and equal strength. That is called doublet flow. It creates a flow pattern with no net mass flow, no circulating motions. It creates a flow pattern with no net mass flow, only circulating motion. Used to model flow around streamlined bodies like cylinders. The velocity potential and stream function describe the flow the important in aerodynamics and potential flow theory for designing shape. If you want a new shape or designing a shape, you first know about aerodynamics and potential flow theory to generate a or designing a new shape. Okay, that is the doublet flow. Then the final one, vortex flow. The vortex flow is a flow where the fluid circulates around a central axis characterized by rotational motion with tangential velocity across the radius. Types free rotational, free vortex, that which means irrotational flow, and forced vortex, that is called rotational flow, and described using stream function, velocity, potential in potential flow theory. Described using stream function, velocity, potential flow theory. It's common in tornadoes, whirlpools, and aerodynamics around wings. This is the vortex flow. These are the overall things about and primary things you know to need and get the knowledge from the fluid dynamics. Okay, I think you can understand each and every topic clearly, I think. And finally, I thank you.